Hi, this is Mr. Merrill. In this video we're going to talk about how to do video analysis in Logger Pro. So this is the default screen you'll open up to in Logger Pro. We actually don't need any of this, so you can click on it and delete each of these. We don't need the graph, we don't need the table, so you should start out by having a blank screen like this. The next thing we want to do is go to Insert, Movie, and the movies can be found on the Moodle site, so it'll probably be in your downloads folder unless you told it to download somewhere else. Your movies have different file names, but this is just an example. So I'll open up this example. The first thing you want to do once you have this movie opened up is click down here. This enables video analysis. We don't need this graph that pops up, so we can press delete with that graph selected. Then we want to resize this, otherwise it'll be kind of hard to see things, so you can click that box in the corner and make it as big as you can. Alright, so now there's a series of things we need to do before we can get any data out of this video. The first thing I'm going to do is make sure I'm selected on this arrow in the top right. This allows me to just click. I'm going to double click on the movie. You should see a screen like this that comes up, and I need to change a few things. First, I want to make sure this is clicked so that my first time is t equals 0. And then it will take forever unless you change this to something more reasonable. We're going to use 30. So this says every time I place a point, move 30 frames forward. Hit OK. The next thing we need to do is define a scale. So you didn't do this in the last video analysis. I just had you read it directly off the ruler. But we can tell the program how big things are by defining something in the picture. So that's why this meter stick is down here. What we need to do is go up to this top right and click Set Scale. Start on this left corner of the meter stick, drag it horizontally across to the right corner of the meter stick, and it's going to ask, okay, that thing that that line that you drew in the video, how big is that in real life? Well, it's 100 centimeters. We're going to use centimeters instead of meters, so our numbers are a little easier to work with. Then hit OK. The next thing we need to do is pick an axis. It doesn't know what you want to call x equals 0. It doesn't know what you want to call the positive or the negative direction. So to set that axis, we're going to go up here where it says Set Origin, the third option down. In each of the videos, sometimes it might be a little harder to see, but about halfway down the rod there shall be a black dot. That's what your origin's supposed to be. If you don't click it perfectly, that's okay. Just make it reasonably close. And you'll see the default is just to have a XY axis exactly how you're used to looking at it. So for instance, this little knob here, this yellow dot, this tells you the direction of positive X, where the vertical would be positive Y. But we want to tilt this axis because we have this motion going down a ramp. And I'm going to tilt the axis, and you do that by clicking on this little knob and dragging. I'm going to tilt this axis so that up the ramp is now defined to be the positive X direction. And you'll see that doesn't perfectly fall on the ramp. You can do the best job that you can, but you're not going to be able to get it perfectly lined up with the ramp, more than likely. So after we've got that set, best we can do, now we're actually ready to record some data points here. So now you have to click on the second option down, and we're going to record data points from the center of the wheel. Okay, so I'm going to click right in the center, again in the center, again in the center. I'm going to keep doing this until the video ends. So you'll have quite a number of data points. Okay. So there, that allows me to record positions because we've set a scale, we've set an axis, and to actually see that data, get that position and time data, what we need to do next is go to Page, add page, okay, the defaults here are fine, then go to insert table. Okay, it's going to give you a lot of data. Now if we had our axis perfect, all these y's would be 0. We wouldn't have any motion in the y direction, but that's okay. The only two columns we need are time and x. Don't ever try to use these velocities over here. Logger Pro does a really terrible job. These velocities are way off. If you actually perform the analysis, these are not accurate in any way, but these positions are fairly accurate, and we only need the x position up and down the ramp. So to delete these other columns, we're just going to press delete, delete, okay. So these are times in seconds and positions in centimeters. So now you can enter those into your table. And for instance, let's do a sample calculation of how you would find an instantaneous velocity, because I think some people still probably need a little help with that. So for instance, we have a time at 0 and 1.2. So what we can do is calculate an average velocity between 0 and 1.2. So we can calculate an average velocity between 0 and 1.2 seconds. And that average velocity between 0 and 1.2 seconds will equal the instantaneous velocity, what we actually want, at the mid-time. So the mid-time of 0 and 1.2 seconds is exactly halfway between those two values at 0.6 seconds. So let's actually perform that sample calculation. Remember that the average velocity is just the displacement over the time, which is the same as the slope of the secant line. So we have two values for position here. So we can do the displacement would be that latter value, the current position, 23.26 centimeters, minus that earlier value, 24.99 centimeters, divided by that later time, 1.2 seconds, minus that earlier time, 0 seconds. If you work that out, give me a moment. Okay, I got a value of, rounding a little bit, negative 1.44 centimeters per second. So that's the average velocity, again from 0 to 1.2 seconds. But because of the property of parabolas, where the secant line, the slope of the secant line is equal to the slope of the tangent line at any midpoint, this is also equal to the instantaneous velocity at 0.6 seconds. Okay, so you can make a table of mid times and velocities calculated in this method.